Hi everyone. So, proving Collatz didn't solve the mystery. And well, what does Collatz say? If n is even, then n over 2. If not, 3n plus 1. So, my proof is pretty simple. We pose the following algorithm: if x divides n, then n over x. Like, yeah, this is a proof. Like, I wanted to show the world. I am not talking about some, it's mine, and it's mine, not yours. So I'm not going to talk about like interesting thing. I don't have time. I have 3 minutes. And in order for we pose this algorithm, you read it. If x divides n in n over x, if not n plus minus alpha over x in n, of course. And in order for n to become 1, we should have this. Why? Because like if this equals 0, then this should be 1, and we are analyzing on 1 point since it's a repetitive function in an algorithm. So we don't care. Furthermore, n should enter the following series: this one x squared x1. Why? Because it gives us 3 and plus 1. So like it's this gives us this, so this gives us this, so both are correct. Be smart. From the previous statements, we have the kn plus n plus minus alpha over x equals x squared over x, which means kn plus 1 equals x, which means kn equals x minus 1, which means k equals x minus 1, which means over n, which means k equals plus 1 plus plus minus alpha minus 1 over n. And since n is a variable, so the only and alpha is smaller than n, like, yeah, because we are doing this as like the last steps. And well, we only have this to equal 0, so that's so which means that this is true. K equals 1 and alpha equals plus minus 1. And case 2, it's x, sorry, case 2, it means this: kn plus n plus alpha over x equals x over x, which means that kn equals 0. And huge note: this algorithm only works for specific values of n with k in n, but with k in k, it works for any n, and those lucky values are 2 and 3. And since 4 and its multiplies aren't always reachable by only adding or taking out 1, from which we generalize to higher powers. So the only one that work are Collatz and Syracuse. X equals 2 and x equals 3. And I have a chance for you guys that is work for negative integers, probably and surely. But for the whole set, it's a real challenge. Anyways, I will defend it someday.